Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is RANO. RAZALI. My meeting number is B0920100234. Okay, today I will go into present solid mechanics assignment, which is the topic force and factor of safety analysis from actual structure. Now we go into our introduction. The factor of safety is defined as the ultimate stress ratio of the material to its working stress. It donates the additional strength of the component than the required strength. Alright, the analysis model for the structure that we use is hammer. We assume material of the hammer is wood and mild steel. Weight hammer is 0.510 kg. Length hammer handle is 0.450 meter. The length hammer head is 0.125 meter. Force applied is 107 Newton, and the angle force applied to x-axis is 30 degrees.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is HAKIMI bin AZHAR. My matrix number is B0920100418. I will present my part for this assignment, which is a free body diagram (FBD). The length from the point A to point B is 125 mm or 0.125 meter. The length from point B to point C is 450 mm or 0.45 meter. For the force, we apply the force is 107 Newton, and for the angle of force is 30 degree.
Assalamualaikum warahmatullahi wabarakatuh. My name is IZZAT NAJMI bin MANSOR with matrix number B0920100065. So I will continue with the equation of equilibrium (EOE). So basically, we obtain the equation of equilibrium based on the FBD, that which is drawn earlier. So equation of equilibrium equals to summation of fx equals to 0, summation of fy equals to 0, and summation of m at point A equals to 0. As we know, moment is equals to force times distance. So we take a look at the FBD, and for horizontal component, we use the force times with distance, which is 107 Newton times sine 30 degree times 450 mm, and we get the value of 24.075 Newton meter. The next one is for the vertical component. 107 Newton times cos 30 degree times with the distance, which is 125 millimeters, we obtain the value which is 11.583 Newton meter. And for moment at point A, we use clockwise direction as positive, so negative 24.075 Newton meter minus with the vertical component, which is 11.583 Newton meter. We get the value which is negative 35.658 Newton meter. So since we use the clockwise direction as positive, so the value become positive 35.658 Newton meter. Rotate in clockwise direction. So that's all from me. Thank you.
Assalamualaikum. My name is ZULHAMIZAN bin ZULKIFLI. My metric number is B0920100046. Today I will explain about external and internal loading acting on the structure. The mechanical response for the structure is shear and moment diagram. The procedure of analysis is showing the support reactions. Determine the all reaction force, couple moments on the beam. FBD is the important for this case. After that, shear and moment functions. Specify separate coordinates x starting from left side of the beam. Section beam at each distance x. Draw FBD each one of the segment. Determine VMM for each segment using FBD. Next, shear and moment diagram. Plot the shear diagram V versus X and the moment diagram M versus X. Better to draw these diagrams under the FBD that you have created.
Assalamualaikum warahmatullahi wabarakatuh. My name is AZHAR. Okay, today I'm going to present about the diagram. First of all, we must do the equation of equilibrium. Okay, so the first step is we must do the summation fx equal to 0. The direction is to the right is positive. So we know is 107 Newton sin 30 is minus, is negative. So minus with AX minus with BX equal to 0. So we will get the answer is AX plus BX is negative 53.5 Newton, and we make it as an equation of 1. First equation. Next step is we do the summation Fy equal to 0. The direction is to the up is positive. So we know that By positive plus with 107 cos 30 equal to 0. So we get By is negative 92.66 Newton. After that, we use the moment. So we put the summation moment to the A is 0. The direction is to the counter with the clockwise. So we put A is the point, so Bx minus times with 0.125 meter plus 53.5 Newton times with the 0.1125 meter plus 92.66 times with 0.45 meter. So we get Bx equal to negative 387.076. They will get the second equation. So we combine with the first equation. So we get Ax is the 333.576. Next is for we get the V1. Okay, we cut it to the left. So the V1 is down and the moment is up. So summation Fy equal to 0 is 92.66 Newton minus V1 equal to 0. Then V1 will get 92.66 Newton. And we get moment. So moment to the D, summation moment to the D is 92.66 times with 0.225 minus 92.66 times 0.225 minus 330 and 576 times with 0.125 plus M1 equal to 0. So we get the M1 is 41.697 Newton meter. Okay, and this is the shear force diagram, which is for the V Newton is 92.66 to the up, and bending moment diagram, the value is 41.697. That's all. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Nur ATIKA binti ABDUL GHANI. My metric number is B0920100047. Okay, the maximum allowable force is the maximum unit stress per meter in a given material used in the verse. The common approach used is known as factor of safety. The allowable force can be expressed in terms of force acting on the members as given below. Fs equal to ultimate force divided by allowable force. From the equation given, to avoid potential failure of the members, we have to find the predicate factor of safety, which is must be choosing to be greater than 1. However, the actual value will depend on the type of material used, which is hammer, and the potential application of the members.
Okay, we continue. From this structure, we predict the allowable force for this structure was 20 Newton, and the ultimate force was found from the calculation for shear force, which is 92.66 Newton. So the answer for the factor of safety is 4.633. In conclusion, we can calculate the approach of this assignment project based on the learning outcome, where we can apply the knowledge of the how to calculate the shear of force of equilibrium equation, analyze the force member from the structure, and we can redraw detail of FBD from the actual structure. That's all. Thank you.